Hi everybody. Today we're looking at how to solve quadratic equations using the quadratic formula. We would use this to solve a quadratic equation of the form ax squared plus bx plus c equals 0. Here's the quadratic formula. It goes like this. If a, b, and c are real numbers, as long as a is not equal to 0, the solutions of your quadratic equation are going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's take a look at a sample problem. So if we were going to solve x squared minus 5x equals 7, our first step would be to get it into standard form. So we would want to subtract 7 from both sides, and so we would get x squared minus 5x minus 7 equals 0. In this case, the a would be 1, the b would be negative 5, and the c would be negative 7. And if we want to use the quadratic formula, then, if we plug everything in, it would be opposite of b, so that's the opposite of negative 5, and then plus or minus b squared minus 4 times a times c all over 2a. So let's work out what this would be. Opposite of negative 5 is a positive 5, plus or minus square root of negative 5 times negative 5 is a positive 25, minus 4 times 1 times negative 7. That looks like a plus 28 to me. And this is all over 2 times 1, so that's all over 2. So we get 5 plus or minus square root of 53 all over 2. That means you really have two solutions to this equation. The two solutions are 5 plus square root of 53 over 2 and 5 minus the square root of 53 over 2. Let's take a look at another example. This one says 16x squared minus 23x equals 17x minus 25. So let's combine like terms so we can get it into standard form. If we subtract 17x from both sides and we add 25 to both sides, we would end up getting 16x squared minus 40x plus 25 equals 0. If we try and use quadratic formula on this, we would have opposite of b, so that's opposite of negative 40, plus or minus square root of negative 40 squared minus 4 times 16 times 25, because in this example a is 16, b is negative 40, and c is 25. Don't forget that this is all over 2a, so that's all over 2 times 16. Alright, for this problem I'm going to just plug all of this good stuff into the calculator. Okay, so let's enter this in the calculator. So let's bring up a fraction template first. So we're going to have as our numerator opposite of negative 40. You could just put in plus positive 40. And then let's do the plus case first. So we're going to do plus the square root of, in parentheses, negative 40 squared, close parentheses before you square, minus 4 times a, which was 16, times c, which was 25. And then this is over 2 times a, so it's over 2 times 16. And when I do this, I push enter, and I get my answer to be 5/4. Alright, now what about the minus case, negative 40, opposite of negative 40 minus the square root? Well, instead of entering all that again, let's just do up click twice, push enter, and then do left click until we can change that plus to a minus. So I'm deleting the plus and I'm putting in a minus. And now I'm getting my answer to be 1.25. Really the same thing. I'm still getting 5/4 as an answer. By the way, I'm interested in knowing what is just this one part of the problem here, just the negative 40 squared minus 4 times 16 times 25, just this part right here. Well, let me do that. So let's see if we can just evaluate just that part. So let's just do the parentheses, negative 40, close parentheses, squared, minus 4 times 16 times 25. There's my opposite of negative 40, minus 4 times 16 times 25. And notice that that part underneath the radical was equal to 0. That's going to be an interesting result for us in just a little bit. Alright, and let's take a look at, so our answer for this problem, if I should write this down, our answer here was x equaling 5/4. Okay, we only had one answer for that problem. Alright, let's take a look at our last example. In our last example, we have opposite of x squared plus 4x plus 5. So again, let's try and get this into standard form. Let's subtract 5 from both sides. We end up getting a negative x squared plus 4x minus 5 equals 0. That means the a is equal to negative 1, the b is equal to 4, and c is equal to negative 5. So our solutions are going to be x equals opposite of b, so that's negative 4, plus or minus square root of b squared, that's 4 squared, minus 4 times a times c, so that's 4 times a negative 1 times a negative 5. And this is all over 2a, so it's all over 2 times a negative 5. So if we clean this up a little bit, we get negative 4 plus or minus square root of 16 minus 4 times negative 1 times negative 5. I think that's going to be 16 minus 20. And this is all over negative 10. Cleaning this up a little bit more, we get x equaling negative 4 plus or minus square root of negative 4 over negative 10. From our last video, you know that if we have a negative number underneath a radical, that is imaginary solutions. So we're going to list our answer here as x equaling negative 4 plus or minus, remember that the square root of negative 4 could be thought of as square root of 4 times square root of negative 1. So that's going to be 2 times I. So in this case it's negative 4 plus or minus 2i over a negative 10. And if we want to clean this up a little bit further, we can split this up into negative 4 over negative 10 plus or minus 2i over negative 10. And it is okay to now divide out 2 into both of these and 2 into both of these. So it looks like our final answer, negative over negative, is positive. So we're getting 2/5 plus or minus 1/5 I, or 1 over negative 5i. That really doesn't matter because you're going to take both plus or minus anyway. So we could just leave that negative off that second one. Okay, so those are our solutions for this problem. Alright, so notice that in our quadratic formula, this part under the radical is b squared minus 4ac, and that has a special name. That part of the quadratic formula is known as the discriminant, and that allows you to tell how many and what type of solutions you will have just by looking at that value of that discriminant. So let's look back at the previous 3 examples. How many solutions and what type of solutions did the equations have? So if we go back to our first example here, our discriminant was what? Our discriminant was 53. 53 is greater than 0. 53 is the discriminant, and 53 is greater than 0, and we ended up with 2 real solutions, 5 plus rad 53 over 2 and 5 minus rad 53 over 2. So we'll say 2 real solutions. All right, what about our second example? In this example, we ended up getting only one solution, 5/4, and we talked about what the discriminant was. We did this on our calculator. we got the negative 40 quantity squared minus 4 times 16 times 25 turned out to be 0. So the discriminant for that example was 0. I'm abbreviating. Discriminant was 0, and that meant we only had one real solution. All right, and in our last example that we just did, I highlighted already the discriminant. The discriminant here was a negative 4. Since that was a negative number under the radical, we ended up getting two imaginary solutions. So let's write that down, that here in this case we had the discriminant was a negative 4, and we ended up getting two imaginary solutions. Okay, so let's talk about how this ties in with the graph. If your discriminant is greater than 0, we said we would have two real solutions. And the graph, that means if we were going to graph the quadratic equation, y equals ax squared plus bx plus c, that graph would be a parabola opening up or down, but the point is it would have two x-intercepts. It would be crossing through the x-axis in two spots. All right, and what about if our quadratic equation's discriminant was 0? Well, then we said we would have only one real solution, and that means if we were going to graph our quadratic equation, it would only have one x-intercept. And lastly, if we were going to, if we had our discriminant b squared minus 4ac and it turned out to be negative, that means we'll have two imaginary solutions, and that means if we're graphing our quadratic function, it doesn't even cross the x-axis at all. Means it would be opening up like this. It would be completely above the x-axis, so it would have no x-intercept. Okay, so that concludes our video for today, and we will be working with the quadratic formula in class next time. I hope you took good notes and that you wrote down 3 questions about this video. See you next time.